Hello, it's Keith here, and today we're going to be doing a special episode and we're going to be discussing MIDI. We're going to be specifically discussing MIDI controllers like this one here. You see, when you connect a MIDI controller like this to your computer and then you read in the data directly from the MIDI port, then you actually get various numeric values from the individual keys. Now, I've been recently writing my own music tracking software called Chibi Tracker Pro, and this is actually able to connect to MIDI controllers, but to be able to make it work correctly with the MIDI controllers and not just read the keyboard and the note keys, but also read in the various devices, sliders, dials, pads and things, and use those in an effective way in the software, I needed to know how those keys would actually output data, the kind of data they would output, and the ranges, so that I could write my software effectively. And of course, there's a near infinite number of different kinds of keyboard, and who knows what ways they actually work. That's what I'm hoping to do today. I've got a variety of controllers. I've got this keyboard. I've also got this slider pad here. No idea what software that's intended to use for. And I've also got this little DJ pad here, and what we're going to do today is we're going to discuss and test these different devices and see what variety of data is outputted from the various controllers, with the intention that if you were looking to write your own software, or you're just curious to know how this format works, the MIDI protocol works, you know, you'll be able to get a good idea of a wide variety of devices, and then from knowing that you'll be able to know how to write your software accordingly. Now, a device like this is very advanced indeed. As you can see on the screen at the moment, I've got some software loaded up, and we can actually, to some extent, configure the different pads to do different things. And in fact, some of the pads actually do multiple things at the same time. These drum pads, for example, in their default mode will act effectively as a second keyboard with pressure sensitivity. We can also change them to CC mode, where they will have, again, they'll act as a controller, but that will output a range of devices, of data. But then finally we can change them to program change mode, where they send a different kind of data again, and then it becomes really just a sort of a case of a number being sent. So these have a really wide range of different options, and I thought it would be interesting to have a look at those. But then when you get into other devices like this that have different switchable banks, and when you get to a strange device like this with directional sliders and buttons and spinning wheels and things, it really, when I bought it, I really didn't have the faintest idea what kind of data it would output, and that's what we're going to look at today. Okay, well, first of all, we're going to go over to the page, and we're going to have a look at a website I found which really has the fundamentals of what you need to know about the MIDI protocol. Now, the MIDI protocol, basically whenever a button is pressed on one of these devices, or released in a lot of cases, a package is sent from the MIDI port, which you can access. I'm doing it from C#, but you can access the MIDI port and get this data. And effectively, there are 3 bytes sent which relate to the button. And then I think there's another 2 bytes, which I don't actually use, but those are a timing sequence for if you needed exact timing. So the 3-byte message that each of these buttons send, and this is true on all of the devices, and it fascinated me because the MIDI standard's so old, but it works so effectively with such a wide range of controllers. But all of these devices have to work within this 3-byte format. Now, the first byte, the top bit, will always be 1. The following 3 bits will define the kind of message. Now, this effectively gives us message values of 8, 9, A, B, and C, D, and E. So that is the possible messages types that we can have. Now, the next 4 bits, effectively the bottom nibble of the first byte, is a controller number. Now, you see, these USB MIDI devices are a little bit basic compared to the more advanced ones with double MIDI ports, but you can daisy chain multiple MIDI devices together, you see. Also, some of these devices actually represent as more than one controller. So the keyboard here is one controller, but then you can configure the drum pads to be a second controller, and they both output what are effectively notes, so A, B, C, D, F, and so on. Even though it's one device, it will actually represent as 2, and this one you can configure to do all kinds of strange things as well. So the second nibble in the status byte is actually a number from 0 to 15, which is a controller number, often represented as 1 to 16 if you've got software control. But anyway, so that's the first byte. Top bit always 1, next 3 bits type of data, next 4 bits are the actual controller number. Now, following that, there were 2 bytes. The first byte, in a lot of cases, in the case of key up and key down, the next one will be the note number, and so this is a number 0, 1, 2, 3, 4, 5, 6, 7 onwards, and this will be sort of C, C sharp, D, D sharp, etc. So that is the actual note type. Now, if you were using a piece of software that could represent different pressure sensitivity, so soft touches and hard touches and things, then the next one you would want to use is the velocity, and that's how hard you press the key. Alternatively though, if you wanted to use the buttons, if I wanted to make this button play and this button stop or something, then you want to ignore that data. Some clever keyboards like this, there is a full level button, and that will disable the pressure sensitivity of the drum pad and things, which may help you out if you're writing your software to read in the data, but you might want to not use that and make your software able to do it anyway, so that it supports devices that don't have that option. So we've got these 8 and 9 are the note on and off. Now, note on is of course the key being pressed down, and note off is the key being released. Now, Chibi Tracker generally doesn't use key up because of the way it works, but it can be programmed to silence a channel, a looping sound only when that's released. So depending on your software, you might want to use both. Polyphonic aftertouch, I've never come across that. Control change is a more common one. This is the B top nibble. Now, the controller number will be passed next, and this is what's used mostly for dials and sliders, but also for a lot of other things as well. And again, we will see that as we start to play with different devices. So the controller number is, the dial number or the button number or something like that, and then the data is the actual data that's outputted from that controller. So it will be the position of the slider and things like that and so on. Now, the format of the MIDI format, the first byte always has a top bit of 1, but the next two always have a top bit of 0, and that means that data 1 and data 2 can only be 0 to 127. So you're never going to see a value of 128 or 255 as a velocity or as data. And this means that basically the data is only ever 7 bits on all of these devices. And as I say, ever since the MIDI standard, the current MIDI standard only supports 7 bits of data for most of these devices. Now, the C nibble is program change, and this is just a program number. And I think this is kind of meant for things like a device with multiple instruments, like if you've got there's a sort of standard general MIDI set with like a French horn and a piano and a orchestral synthesizer or something weird like that. And I think that's primarily meant for those instrument changes, but you do see this data outputted by other devices. And as I say, this keyboard in particular, there is a program change button, and then these pads will output different numbers. But again, if you write in your own software, what you want to use those program changes for is entirely up to you. Channel aftertouch, another one I've not seen, I don't think. The final one is pitch wheel. Now, each device can only have one pitch wheel, and the reason for that is that both of the 2 bytes are entirely allocated to the least significant and most significant bytes of that pitch wheel setting. Now remember that 1 bit, the top bit, is always 0, so this means that the 2 bytes together make a 14-bit pitch, a pitch shift. And so this keyboard may not look like it has a pitch wheel, but this slider, I think left and right, is set to operate as a pitch wheel, so we will see that as well. So as I say, what we're going to do is, through the power of my Chibi Tracker software, we're going to try out these keyboards, and we're going to see that the data that all of these different kinds of button will output in their various settings. So let's go over to the other screen and let's have a look. Okay, so I've got my various MIDI devices here. The first problem you have with these is getting them all connected. Sometimes they respond a little bit differently, especially this one, which has its own built-in sound card. So when I plug that in, my microphone will probably break or something annoying. But generally speaking, they don't need, none of these need drivers with any kind of modern Windows, even Windows XP, I don't think. So that's one problem that we have averted. Now, what I'm doing with today to test this is I'm using my Chibi Tracker software, which connects to the MIDI port, and it actually outputs the raw data from the port as I press the buttons. So if I press this button here, you can see we've got a value 903022. Now 90 means that the key is pressed down, the 9 is key down, 0 is the device number, this is the keyboard is device 0 as it's set up, and then the 30 is the key number, that is key 30, that is key 31, that is key 32 and onwards. So that is the key number, and then if I press softly we get a value of 1. If I press hard, we get a value of 6740. These are hexadecimal, so the maximum value you could get for the velocity would be 7F. So that's how those work. As I say, a lot of this keyboard, there are multiple modes. This bank option allows me to toggle the bank for the dials and the pads here. So we'll see this. As I say, the keyboard itself, key down is 90, key up is 80. Feels like it should be the other way around, but that's the way this works. And then if I press these pads in this mode, you can see we're getting 9-1 and 8-1. The 9 and 8 are key down and key up again, and the 1 means that it's a separate controller, and that's how I've got this configured at the moment. So that's controller 0 and that's controller 1, but they are basically effectively the same keyboard, and this is outputting C, C sharp, D, etc. in the same way in regular mode. Now if we press the bank button, we'll get different values for the key, but the way that it works is still the same. Now the dials here, if I press these, you can see we're getting B0. Now B0 is controller change, the controller number is 0 there obviously, and then you can see when I go to the far left of this dial we get a value of 0, and far right is 7F. Remember 7F is the absolute limit of a 7-bit value, so these are outputting the full range when we turn the dials, and the controller number is different depending on the dial. It is configurable on this from the software on this keyboard, but as I say, basically speaking, these are functionally all the same. It's just the controller number that differs. Now if I press these by default, remember these are appearing as notes 8-1 and 9-1, but if I press CC, these are now outputting different values, and I've actually got this configured so that the different banks work differently. With the red bank set, if I press these, you can see they turn on and toggle off. Now they're outputting a status of B, which is controller change, which is the same effectively as these are here. But you'll notice when I turn these on and off, when I turn them on they're giving a pressure sensitivity, and when I turn them off they're giving a value of 0. Now of course if I turn on the full level option here, you'll see now they only give 7F and 0. So again, how you want to actually use these might depend on how your software wanted to work. I mean, yeah, I could imagine these being used for like enabling special effects like echo, or you know, maybe changing panning positions or something like that. But you wouldn't want the pressure sensitivity in that case. So now the second bank, I've changed these, and these are just temporary. You can see when I press down that says 7F, and when I release that says 0. But again, that is pressure sensitive. So depending on how hard I press, so this might be good for sort of play and stop functions or something like that. I don't know. That's the CC option, and as I say, even though these are very different buttons to these dials, they are both using that B function, that B top nibble, so they are actually appearing as the same kind of functional device, which I wouldn't have expected, you know, but that's the way it works. Now program change is much simpler. If I press a button now, well, we're getting a status byte of C1, C being the program change command and 1 being the device number, and then these are just outputting numbered values, and I've programmed the numbered values that they output. These can be configured within the hardware by itself via that software I showed you earlier, but as I say, generally speaking, you know, these are much simpler. But if depending on your software, I've tried to make Chibi Tracker as compatible as possible so that you can use either of those kind of functions. Now this is the joystick. Now up and down are outputting a B value and 1, which means controller 1 on device 0 is giving a value, and full down is 0 and full up is 7F. So it's using a single CC code for both. I think you can configure it to use 2 CC codes, 1 for up and 1 for down. But the left and the right is very different. Now these are outputting the pitch bend. Now I was using a simulated MIDI piece of software, and that was outputting all kinds of crazy values, but it seems that this outputs the more logical values that I would have expected. Now if I press far left, E0 means E is the pitch bend, 0 is the device number, and far left is just 0. Far right, on the other hand, is 7F7F, which is a 14-bit value at full value. So that's entirely as I would sort of expect. But as I say, the simulated one on my Windows XP virtual machine that I was doing my development on, that was just outputting all kinds of crazy stuff. So yeah, something maybe to bear in mind there. Now, one other thing that I probably should just tell you is we do have octave up and octave down buttons on here. Now these don't actually output any codes to the software via the MIDI port. These actually change the data that the keyboard itself outputs. So if I press octave up and press, I'm pressing these two, but then if I press an octave down, the numbers that it outputs are different. So the octave buttons are actually changing the data sent, and they're not passing codes to the software, which it makes perfect sense. In some ways I would have preferred it the other way, but there, I'd say, just something to bear in mind maybe. Now this device does allow for multiple programmed sets of settings via this program change button, but to be honest, they're all basically, as I say, you can configure things whatever way you want, but the fundamental functionality that this keyboard offers, I think I've explained it all now. So it's a very interesting device, very capable, yeah, this is about $100, so it's very cheap for a lot of configurability. So certainly one to consider. Now we're going to have a look at this one next. I got this one secondhand for $10. It wasn't something I particularly planned on buying, so to speak, but it is when you're looking to test as many devices as possible, getting a cheap one like this, it was certainly worth having a look. So let's plug it in. Let's hope it works. As I say, sometimes plugging all of these MIDI devices in one after another maybe causes some issues. Okay, we're in luck. It took a while to detect, but it's working. So again, basically this one in a lot of ways is very similar and a lot of ways simpler. Now we've got these dials again. Far left is 0, far right is 7F. These are outputting via the B controller change option again. So these are just analogs, sliders all the way up 7F, all the way down 0. You can see that the second byte is 2 for that one, and it's E for that one. Again, each of these is outputting a different controller number, but basically all of these sliders and dials exactly the same, full range of values there, nothing particularly exciting. I don't know if there's software to reconfigure this one. I've not got it if there is. Now, again, the only maybe more interesting thing is that these buttons here, these are outputting B as well. So this is a slider, and this is actually outputting an effectively a slider value, but you can see again, down is 7F, up is 0. So these obviously have no pressure sensitivity. The numbers that they're outputting, I don't understand the combination of them. You know, I don't understand how they're calculated, but the way I've programmed Chibi Tracker, you can click a button to map a key and then press one of the keys or dials and it maps it automatically. So I don't need to know which numbered devices are being output. I just need to understand which buttons are outputting a range and which buttons are outputting two values and things like that. So these are also outputting in the exact same way. They're just outputting different numbers. Nice play and stop buttons. I do kind of wish this had play and stop buttons, but it doesn't. It would have been nice to have that sort of simplicity. Now, the only other interesting thing I thought about this is we've got this button here, which you maybe can't see. It's marked scene, and if I press it, we toggle between 4 different LEDs. And you'll notice when I'm pressing this, nothing's happening. But if I change this slider at the moment, that's giving a device number as 2. But if I press it again, it's now 55, and now it's 7, and now it's 2. We missed one, 2A. So the 4 different devices are outputting different values for all of these buttons and dials. So I guess this is, I mean, this is like 9, but I guess this is, so you could maybe control 36 different volume levels. Maybe these are designed for volume, and these are for panning, and these are for mute and solo or something. I really don't know what this is designed for, but very nice. I do like these up and down dials because you can immediately look at them and see their setting level, and I thought this was quite a clever way of doing things. And again, like this one, rather than the button telling the software what to do, the button is changing what the hardware is telling the software, which again was sort of a surprise to me that the hardware itself is so active in this. So there's not really much else to see in that one. As I say, all of the buttons are 0 or 7F for off and on. The dials all full range. Everything on this is outputting a B0 value, I think. I don't think there's anything else. So it's sort of a nice simple device, but very very clever, and I'm sure if you knew what software to use it for, it'd be quite interesting. Now this one has its own built-in sound card. We're not going to use that though. All we're going to worry about today is the MIDI functionality. So if we just get our Chibi Tracker to connect to this, there we go. So this is the sort of big daddy one. There's a lot of different options here. So we've got sliders up and down, left and right. Now, one thing that I was sort of curious about, now this is outputting BF as the control byte. Now B again is just a controller, and the F means it's responding as device 15. Now I was a bit sort of unsure as to whether this would output on two different channels or whether the center would be 0 or something like that. But it seems hard left is 0 and hard right is 7F. And that's true of these as well. This one's outputting 0 here and this one's outputting 7F here. That's B0, that's device 0, controller 9. This one is device 1, controller 9, 0 at the top, 7F at the bottom. So the center isn't 0 or anything, which slightly surprised me there, but that's the way these work. We've got a variety of dials here. 0 to 7F here, 0 to 7F here, 0 to 7F here, and we've got 0 to 7F here. Accidentally touching the dial there. So it seems that this controller on the left is a device 0, this controller on the right is device 1, and anything that's shared common to the entire sort of platform is device 15 here. So that's what the F is in BF there. So we've got various kinds of button here. Now these are actually outputting as effectively note keys, which is very different to the way that the buttons on this one worked, which were acting as controllers. Now, from the point of view of programming the software, it really doesn't matter as such what they output as, but you of course need to know that. Again, they're outputting down and up. 9 is the key down, that's the key up. Now, these ones are outputting as device 0. These are outputting as device 4. But I've got this option here that can switch between 4 different modes. If I press this, you can see we're outputting on device 3 of controller 4. If I press it now, we're on device 13 of controller 4, 23 and 33. Now on the other side, we're on controller 5, but it's working in the same way. And again, when we toggle between them, we're getting different options. So these LEDs are marked as cues, auto, manual and sampler. So these are designed for the sampler functionality relating to each of the channels, which is why there's 2 and why they respond on opposite sides. Now here we've got the headphone buttons here, and these again are outputting as note keys, which is a little bit uncommon. As I say, all of these other devices, those kind of buttons tended to output as a controller, but not on this one. Now the final thing that I was really quite surprised by and quite impressed by, to be honest, was the dials, because I didn't know how these dials were going to work. Firstly, from a point of view of how they outputted, but also how the software, the DJing software, would actually simulate a turntable with just a dial. So basically, if I slide these, you can see these are rotary encoders, and what they're doing is, if I turn this one direction, I'm getting a value of 1, which is +1, and if I rotate it the other way, I'm getting 7F, which is -1. Now if I turn it very fast though, you will see I'm occasionally getting a value of 2 and a value of 7E. So they're actually responding depending on the speed. So if I turn these faster, they're outputting higher or lower values depending on whether the turn is to the left or the right. Now this is also a rotary encoder. I don't think that one ever outputs a value of 2 or -2, but it's a rotary coding kit as well, and we've got a push button there. Again, that's responding as a note key. And those are responding, all of the buttons respond as note keys on this, which is, as I say, is a bit surprising compared to what I'd seen on the other devices. Now, the one final trick these turn wheels have is if I put my finger on them, I think these are capacitive, they can detect my key press. So you can see here I'm pressing down, and again, it's responding as a note on different keys here. Doesn't seem to respond to the pressure sensitivity, which doesn't matter. But I'd say the clever thing with this is if you turn these while the music's playing without touching the top, it will make a slight slowdown and increase to the playing speed. But if you touch the top, it will stop the record, and then you can use it for your scratching effects, which I thought was a very clever way of using a single controller to give 2 very different effects on the playing music. So I'd say a very interesting little device. I don't really have any intention of using it for playing music, but I needed to know how this worked and how the rotary controllers would output different values to the software. And I was really quite interested by the way this worked and the design of it. So anyway, now my understanding is that these kind of DJ controllers don't all work in the same way. That would be certainly implied by the fact that the mix software that has different profiles for different hardware. And actually, these sliders were inverted. They're actually the wrong way around in the profile. So it seems pretty likely that not all devices work in the same way. But as I say, being as we've seen 3 different devices today,
and we've seen the range of functionality they have. And I've actually got this this fourth little one as well, but that's another Akai, so it works in basically the exact same way as this one. But I think we've seen a range of devices and the range of the different data output that they exhibit. And so if this was of an interest to you, then hopefully you've learned a little bit about the kind of data they output. Now, my Chibi Tracker software, if we just go over to the other window here. So my Chibi Tracker software here, and what I've got is I've got profiles here. And so when I want to set a function to something, so for example, key down, if I use the set button here and then I press anything on this keyboard, like I press this key, note key here, now it knows it's a note key because it's got the 8 or 9 byte in there. And then when I press this, it's now sending a key down to the software. I can also use dials to set things. So for example, I can click on the instrument and then press set. Now if I turn a dial, well, now I can use this dial to set the instrument number. So I've got this sort of software configurability so that hopefully it can work with any kind of device. Any of these should work with it pretty well, and any device that works in a similar way that I've not yet tried. So anyway, that's all I'm doing today. I know a bit of a weird lesson and probably not very interesting to some of you, but if you're into MIDI and you've never looked at the hardware side, maybe it's interesting. And if you're looking to program and you're looking to, say, work with MIDI devices and don't want to have to buy a stupidly large number of them, maybe this has helped you out. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching and goodbye.